Hello everyone, it's me again. I'm sorry for the issues in the other video, so I decided to record this again. Hopefully it's going to be better this time. Let's get to the solution real quick. I want to keep this quick, okay? So, as you know, we have a square that's inscribed in the region between the two quarter circles and a unit square as shown. We're going to find the side length for the square. So, what I'm going to do is I'll be making some connections as you know here. Let's start with this one, okay? And I'll extend the side length for the square. So it's going to look like this. All right. So I'm going to call this X everywhere. X, 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 S. Okay, awesome. And then, we'll be making one more connection to take advantage of the radius of the quarter circle. Okay. All right, awesome. So here's what we're gonna do. We're gonna call this H. As you know, this was X and this is also H. And then what else do I know? Okay, since the radius is 1, this is going to be 1 minus X. So I have one right triangle here and then another right triangle here. Okay? Awesome. All right, so let's go ahead and write down the Pythagorean theorem and let's get to solving this. And as you know, this is going to be the radius, which is 1. And the hypotenuse here is also 1. So both hypotenuses are 1. So the first one, 1 minus x squared plus h squared is equal to 1. Okay, so what I'm going to do for this one is basically simplify this. Let me go ahead and do this. So it's going to be 1 minus 2x plus x squared plus h squared is equal to 1. 1 cancels out. And then we can go ahead and isolate h squared here. As you know, it's going to look like 2x minus x squared. And if I square root both sides, and I'm going to be getting this one. Awesome. Let me go ahead and write down the second equation. H plus x, we have h plus x squared, right? Plus x squared, which is the base, obviously. And the hypotenuse, again, is 1. Now, what I'm going to do is I'm going to use this in the other equation, substitute that, and I'll be getting hopefully x from here. Okay, let me go ahead and do that. This is going to be the square root of 2x minus x squared plus x, and the quantity will be squared, plus x squared is going to equal 1. Now, one of the things I can do is obviously I can just isolate the radical, which is going to be a good idea, I think. All right. And then what am I going to do? I'm going to expand this. Let's go ahead and do that here. And it's going to give us like a plus b squared. So a squared plus 2ab plus b squared, which is x squared. And then this one is already, what it is. We don't need to worry about it. So x squared cancels out. So what I'd like to do here is, actually, I want to isolate the radical here so it looks like this. All right. And then I'm going to subtract 2x from both sides and I will square both sides. And that's going to be a good thing to do because then I'll get rid of all the radicals. Hopefully, I will solve this equation. Okay. Now, this is a product, so the square is going to look like this times that. And this is going to be 3 terms. So think about a plus b plus c quantity squared. It's going to be like a squared plus b squared plus c squared. And as you know, we have the 2ab, which is minus 2x squared, 2ac, which is minus 4x, and then plus 2bc, which is plus 4x cubed. Don't forget to double the products because that's what you have in the formula. Okay, let's go ahead and distribute this. 8x cubed minus 4x to the fourth is equal to x to the fourth plus 4x cubed plus 2x squared. I'm kind of simplifying these as we go, minus 4x plus 1. And what I'd like to do is put everything on the same side so that I can get a nicer expression, which is a quartic. Well, not very nice, but it's okay. All right, I'm going to bring this 8x cubed as a minus sign, so it'll be subtracted. That's going to give me minus 4x cubed. So we've taken care of these and these. And then I have the 2x squared minus 4x plus 1. Awesome. Now, what do we have next? Well, this is a quartic equation, so it's hard to solve. But notice one thing about these equations with polynomials. Of course, if we can't find something like this, then it's very hard to solve. But if you look at the coefficients, I noticed that 5 plus 2 plus 1 is 8, and negative 4 plus negative 4 is negative 8. So this tells me that the sum of the coefficients is equal to 0, which means x equals 1 is a solution, which means x minus 1 is going to be one of the factors. Now, there's obviously a way to manipulate this, right? But I'm going to keep it short. So what I'm going to do is you can also do a polynomial division to keep this video short. All right, so just bear with me. I'm going to give you the factors. Okay, so basically this is what you get after factoring this, or, you know, just doing polynomial division. Okay, now x equals 1 is a solution, but I'm not going to accept it because do you think that the side length for the square can be 1 when it's inscribed in a, you know, square like this? It's not going to work. So we're going to discard it, but we're going to go with the other solutions. Now, I've done this cubic for you, and I also included the link in the previous video, but I'm going to do that in this one as well. So you'll get to see the Wolfram Alpha solution. But basically, this equation has one real, two complex solutions. So if you would like to see those, they're really gigantic. You can see them in the link provided below in description. Okay, so but without further ado, I'm just going to go ahead and give you the solution to this equation, which is, you know, kind of fun to look at. And x, the value of x that we'll accept is going to look like this. We have 1 over 15 times the quantity negative 1 minus 22 times the cube root of something. So this is kind of like a gigantic expression. So I try to simplify a little bit. I guess I wasn't very successful, but you know, it's a little better than the original. And then this needs to be added to something else, and that's going to look like the cube root of 404 plus 60 times the square root of 69. And you'll probably notice that this expression is 4 times this expression because we had the cube root of 4, but I just included it in there. And by the way, this parenthesis was placed in the wrong place, so it should be here. There you go. 1 over 15 should be the coefficient of everything. Okay? So thank you for your patience. And I seriously, I genuinely apologize for the first video. I don't know why technically it turned out to be that way, but hopefully this is going to be a good one. And thank you for watching. I really appreciate your support. Please comment, continue to comment and like the videos, and I will continue with more videos. And thanks for everything. You have a good one. Bye-bye.